Please welcome Tarun Jami from Green Jams on stage as he showcases his innovations that is being applied in real-world scenarios. Can we have a big round of applause for Tarun?
Okay, I don't know if my presentation is coming up. Okay, here it is. Good morning. I'm Tarun Jami. I'm the founder and CEO of Green Jams. So I'm basically a civil engineer. I have a master's in environmental forensics, PhD in civil engineering. I essentially sort of a pioneer in the space of bioconcretes. So the fundamental problem that we're looking to solve is, of course, the large environmental impact of construction. But the question that we're actually looking to answer is, what if buildings could help reverse climate change without burning a hole in the pocket? And the larger mission that we're on is to remove 10% of global CO2 emissions. So, yeah, I jumped the gun. So the answer to this question, what if buildings could help reverse climate change, is Agrocrete. It's the world's first verified carbon negative bioconcrete. We make it using crop residues and byproducts of the steel, construction, power, mining, and other industries. So we have patents in India, the UK, Thailand, South Africa. By the end of the year, we'll have patents in Europe, US, Australia, and other locations. So as I was mentioning earlier, we're talking about a bioconcrete, which essentially means that, you know how concrete is. It's like water. It does not have a shape or form. The function always follows the form. You put it in the form of a brick, it's going to perform the function of a brick. You put it on a floor, it's going to perform the function of a floor. So when we first started out, the lowest hanging fruit that we realized was bricks and blocks, right? I mean, it's a huge market. Everyone, I mean, almost 87% of construction that happens in the country today still consumes bricks and blocks. And also, I mean, it was just much easier to just make a brick and sell. But however, as we go forward, the end vision for us is to replace entire concrete with Agrocrete. Gives us the maximum amount of potential for carbon capture, for improving aesthetics, for improving thermal insulation, and so on. But anyway, back to feet on the ground. This is what we're doing at this point. We're making bricks and blocks. So we essentially make Agrocrete blocks in different forms, shapes, sizes, ranging from 5 to 15 megapascals in strength. We have best-in-class thermal insulation. And the most important component, the embodied carbon, is in the negative values at the manufacturing stage. And I'm going to talk about how. So this is the manufacturing process. It's a 100% upcycled material with 0% emissions. It's based entirely on an advanced alkali activation chemistry that I developed and patented. So it begins with a collection of crop residues. We chop it up into small particles, keep it aside. And then we have the filler materials. These include ashes from thermal power plants, reclaimed construction soil, your residues from mining and from construction industry, and so on. And third comes the most important component, which is the cement alternative. Biomass and cement, unfortunately, don't go well together. You put crop residues in cement, it's not going to set. There are a lot of engineers in the room today, and I want to take you back to engineering days when I'm sure the professor must have joked about adding sugar to a neighbor's concrete mix in case you have a grudge on them. It wouldn't set. So, which is essentially why we ended up creating an alternative binder, which is made entirely from 4 different types of slags from the iron and steel industry, which we grind and activate in our proprietary process. Finally, it follows the exact same methods that you would for creating concrete. So you mix all of them together in a pan mixer, and you mold them into the shape of blocks. And voila, 7 days later, you have amazing bricks that help you reduce construction costs by up to 50%, improve the building's thermal insulation by 3.5 times, In fact, we've been able to demonstrate this in several buildings. An office building that was made with Agrocrete was able to achieve an EPI of just 60 kilowatt hours per meter square per year. The ECBC benchmark is 120. And eventually, we're also helping our customers be able to capture carbon dioxide in their buildings, so eventually achieving a negative embodied carbon for the total building itself. Just going to skip this. I think the most important point to note here is approx 1.8 crore rupees, at least 1.8 crore rupees of construction cost saved. Yeah, so I mean, so far we've already sold about 1.5 lakh Agrocrete blocks to the market. We've completed 15 projects now. We have a 90% customer retention rate, and some of the largest names in the industry basically use Agrocrete for various reasons, including thermal insulation, cost reduction, lowered embodied carbon, and carbon capture. So this was the first ever first ever project actually that we ever did. This is a 1.8 kilometer long boundary wall that we supplied the blocks to for a project of ITC. The total carbon that we were able to sequester in this was 38.5 tons. And so we've also done residential buildings. This tiny building consumed just about 1,100 Agrocrete blocks and was able to capture almost 2.1 tons of carbon dioxide. And this is a 10,000 square feet mixed-use building in Vijayanagaram, Andhra Pradesh. Quite a hot place. It was actually, in fact, in this building that we were able to achieve an EPI of just 60. Also, we're able to capture about 4 tons of carbon dioxide here. And some more individual residences. This is a building that's very close to my heart. This was the first ever structure that we built. This served as my workshop for a year and a half while we were doing all sorts of R&D in there. And what's amazing about this building is we do not use any cement. We do not use any steel. It's a small shed, but so just made completely in load-bearing masonry with our blocks. Has already withstood 3 cyclones, 2 minor earthquakes. It's in Roorkee. And here, we'd actually been able to do a full analysis, and we were able to establish a minus 3.1 tons of CO2 total embodied carbon. Yeah, just going through some other projects that we've done. In fact, this is another very interesting building. This is coming up in Goa. 10,000 square feet, potential to capture almost 45 tons of carbon dioxide. And what's amazing here is it's a completely load-bearing structure. So the walls perform the function of your the structural walls. And the roofing is basically done with timber and stone. Yeah. So I already heard the buzzer. I don't know if my 15 minutes are up already, but yeah, so we've received quite a few government grants that helped us scale the business, and that's about it. I'm happy to take questions right now. Thank you. Oh yeah, so we're rated for 6 hours of fire rating. I did not mention that, but yeah.
6 hours?
Yeah.
What's the biggest barrier for adoption? Is it your production capacity? Is it specifications by architects? Something else?
So scale up, I think, is driven by, it's a catch-22, as you might imagine. So of course, there is a fairly small amount of production capacity at this point, because of which we haven't been able to get into larger buildings. But we're solving for that at this point. We're doing contract manufacturing. But yeah, we do have several people specifying the project. Most of it essentially comes from asset owners, folks who are motivated by preferential financing terms because of better environmental credentials.
This will take a last question.
How do you reduce the construction cost by 50%? What are the levers?
Yeah, I mean, so through different ways. I mean, what we're comparing here is the total cost of a built wall. So building with Agrocrete would, so for example, you're building a 9-inch wall. 1 square meter would cost you about $1,250 with Agrocrete, compared to a conventional burnt clay brick is somewhere around 2,500 rupees per square meter. So larger block sizes, 80% reduced mortar consumption, 2.5 times increase in labor productivity.
Okay, thank you.
Thank you so much.
All right, thank you so much.
Tarun, wait.